Gravitational field strength. It's also known as gravitational gravitational field intensity, or sometimes it is also known as gravitational flux density. All these three terms are exactly the same. Gravitational gravitational flux density. All these terms are basically the same. They're all represented by small letter g. Now, we have already seen what does it mean by gravitational field qualitatively. So we know that at every single point, the gravitational field has a specific value both in magnitude and then it will have a specific direction. So how do we find out the gravitational field strength at every point? So it's a vector quantity. This is a vector quantity. All these things together, this is a vector quantity. And we will define gravitational field strength or gravitational field intensity. Let us define it first, so the rest of the things will be not easy. So the definition, I'll just make it. Let's look at the definition first. I hope this idea will be clear then. Now, every single point will have a specific vector representing the gravitational field strength. So this is defined as the gravitational force per unit mass. This is known as the gravitational field strength. Gravitational force per unit mass. So if I want to find out the gravitational field strength at this point P, if you want to find out the gravitational field strength at this point P, we will keep a body of mass m here. Let us keep, this is called a test mass, a small mass, we call it a test mass. We keep a small mass m here, and then we will measure the gravitational force on that small mass. And let's assume that the gravitational force acting on the small mass m, point mass of m, let's assume that it experiences a force F in this direction. This F is a vector quantity. In this case, gravitational strength, field strength, in this case, gravitational field strength at P, at the point P, is given by G. Let's assume that this is at the point P, so we'll write it as a function of P. Does not really mean it's a function of P, it may be a function of many other things. Just to indicate that we are defining at the point, or it will be better, let's use the, just leave it as G at, let's put it as an index rather than is equal to, or let's leave everything alone. Why? You will get confused. G is equal to, we can write this as G is equal to, what is the force? The force acting on the test mass M is F. So you call this as test mass. This is called test mass. Can be any value of any value. Usually it is taken as small mass test mass. All right, this is the test mass. So G is equal to the force, of course it's a vector, over the test mass m. M is a scalar quantity. So this is the expression for the gravitational field strength. The general expression for the gravitational field strength is this. I wish I could leave it as it is. The force per, so in simple terms you can say that gravitational field strength or intensity, you can simply say of gravitational flux density. So gravitational field strength gravitational field strength is equal to gravitational, right, force over mass. So you could say, so it looks better now. We have seen that equation. G is equals to F upon M. We can write the bird equation like this. And we can say the definition is force per unit mass. In simple definition, okay, in simple definition, you can simple definition. Gravitational field strength is gravitational force per unit mass. So you will be able to remember this better. Let's try to work out the unit of gravitational force. Okay, let's come over here. Use a different color. Unit of unit of gravitational field strength or intensity. Intensity. Let's for a change. Let's write it as intensity. The same as strength. Now look at here. We use the expression. It's pretty easy to work it out. We have the expression G is equal to F over M. Therefore, unit of G, unit of G is equal to unit of F over unit of M. F is force and M is mass. So you will see that in SI system, the unit of G is equal to Newton per kilogram. Ah, Newton per, oh, what a funny letter. Newton per kilogram. Now the Newton in base units, Newton can be written as kilogram, Newton is kilogram meter second to the power minus 2, and denominator is, sorry, kilogram. So you get the expression unit of G, base unit of G is meter second to the power minus 2. Please remember this is exactly the same as the unit of acceleration. So right here it is the right same as unit of acceleration. So unit of gravitational field strength is same as the unit of acceleration. So to differentiate it, for acceleration, A, you will write the unit meter second to the power minus 2. And for gravitational field strength G, gravitational field strength G, we will write the unit as Newton per kilogram. So you can differentiate them if you want. Newton kilogram inverse, though both are the same. Essentially, they have the same base unit. So they have the same base unit, just remember that. Same base unit. So this is the expression for gravitational field strength. So let us say, try to find out the gravitational field strength due to a point mass. So we will see the gravitational field strength due to a point mass here. So gravitational field strength due to a point mass. Point mass means you can use a spherical body of finite dimension. Then you can consider the center of mass of the sphere as the point. So let's work it out. Here we have, let's assume that here we have a body, okay, and the mass of the body is capital M. Now let's mark a point here. Let's mark it as P. This is the point P, and we are trying to find out the gravitational field strength at this point. So we will draw a line from the center of mass of M to the point P. So the distance, if the distance is R, now if I put a small mass, test mass here, I'll put it in a different color so you'll not get confused. You're going to put a test mass here. Let's assume that this is a test mass M. This is the test mass. What is the purpose of the test mass? To measure the force. This is the test mass. The purpose of the test mass to measure the gravitational force at this point, and you divide it by test mass and you will get the gravitational field strength. Okay, now here we have the gravitational force acting, because the gravitational force is attractive, so gravitational force will be acting in this direction. This is F. Now we know the value of F from Newton's law. From Newton's law we know that from Newton's law of gravitation, gravitation, the we know that the gravitational force on test mass M, that the gravitational force on the test mass M, on the test mass M is given by F is equals to, this is just Coulomb's law, G m m over r square. Now we can find out the gravitational field strength. Therefore, gravitational field strength at P, let's write this as G, that is equals to F over the test mass m, that is equal to G m m over r square over m. So you will get the gravitational field strength G is equals to G m over r square. This is the expression for the gravitational field strength due to a point mass. Now, because it's a gravitational field strength is a vector quantity, the direction of the gravitational field strength is the same as the gravitational force. So, direction of G, what is the direction of G? Same as the gravitational force. So, direction, of G is towards the mass. Again, if you use the sign conventions, we may write in a different way using the signs, because R, R is always, I'll just put the same color and make it clear to you. This will be the direction of R. Okay, this is the direction of R. You can see that. And F is in the opposite direction. So F and R are in opposite direction. Uh, Since F vector, F is a gravitational force and R is the distance to the point P, are in opposite directions, opposite opposite directions. They're in opposite directions. So you may write. So you may write. You may write F is equals to minus G m m over r square. In that case, G can also be written as negative G m over r square. In this case, the negative sign tells you that the direction of the gravitational field intensity is opposite to the direction of the r, or attractive. This negative sign implies only one thing. Negative sign implies that gravitational force is attractive. So this is the idea of gravitational field due to a point mass or a spherical body. Let's try to plot some graphs just to see how we can represent the variation of the gravitational field strength with distance. Okay, let's take a look at the graphical descriptions. Let's do some graphical descriptions for the fun of it. Graphical description. Now let us plot a graph between the G and R square graph. So first we will try number one. We will have G R graph. The GR graph, this is actually gravitational field intensity versus the distance from the center of the for a spherical body. Okay, graph. That's right. For a spherical body. For a spherical body. So we are only doing in case of spherical bodies. Okay. Let's have a graph in here. So I'm going to draw the lines. Okay, I can even use this one. Different color I'm going to use. Right, okay. Here we have the axis. Right. Okay. Now here I just have x and y axis here. Of course, gravitational field strength is negative, so you will have the negative values primarily. So would it be yes or no? It doesn't really matter. Here we go. This is the y-axis. So I will just erase all these things, make it look better. All right, it's better to see that I can. So this is on a negative side because the gravitational field strength is negative. It is gravitational force is attractive. That's the reason why we get it negative. Here we go. So, all right, let's put it on 8 again. Now, let's assume that we have a body here. So it's a little bit difficult, but I'll try my best. So here we have the body with its center. Okay. Oh, sorry. I forgot to. All right. Here we have the body. All right. Doesn't look nice. A little bit better. Okay. So here we have the body of mass m. So how does the gravitational field strength? Gravitational field strength will be close to the thing. Gravitational field strength will be high, and as we go further from it, it will go lesser and lesser. So this is high, negative, of course, then it become lesser and lesser. So we will have it only from here. Watch how the graph goes. Let's see how the graph goes. Wait a minute. So the graph is parabolic because the expression is inverse square law, so inversely proportional to the square of the distance. So this is the way the graph. I'll try to draw the graph in here. All right, here we go. On this side, here we have the maximum, and it goes parabolically on this side. And you will have the same thing here, symmetric, and you'll have the maximum on this side. So this is the way it goes, but on negative. So here on the y-axis we have G, that is in, let's say, Newton kilogram inverse. Here we have r and meter. So it's parabolic. You get parabolic graph in this case. Okay, here parabolic graph. So here we have considered negative sign. This is the expression we have used. G is equals to minus or negative Gm over r square. This is the equation we have used. Well, in all these equations, you shouldn't get confused with this negative sign. This negative sign only implies that the gravitational field strength is towards the mass which causes the gravitational field. That's the only meaning of it. So even if you see equations like this, G is equal to, either you can write G is equals to Gm over r square. This is exactly the same as writing G is equals to negative Gm over r square. For point mass, with the expression for point mass or a spherical body. Spherical body. The negative sign, what is the implication of the negative sign? The negative sign only tells you about the direction. It does not mean anything. You just better had that point. Negative sign, negative sign indicates the direction of the gravitational field strength. So either way you can do it, it does not make any difference, because the negative sign will tell you that the gravitational field strength is towards the source. That's the only meaning. Gravitational field strength is towards the source. What is the direction? I'll mark it here in bracket, i.e. gravitational field strength is towards uh, the source which generate the gravitational field.